Hello everyone. Welcome to an informative webinar by Royal Cyber. I'll be your host and the speaker for today's webinar. Some of the ground rule for smoother experience before we begin. I'll be going through this webinar as per the agenda, and in between, if you have any queries, feel free to post to us on the chat window. There will be a dedicated slot for Q&A at the end of this webinar. You can also write your queries to this email ID, namely info@royalcyber.com. We will be sharing this webinar survey form at the end of webinar. Please do fill in and revert back to us. Now, today's topic about webinar is mainframe source code management migration to GitHub, and I'll be the speaker for today's webinar. Myself, Vijayalakshmi, manages mainframe practice here at Royal Cyber and helps our customer for mainframe modernization and migration solutions. Here is the quick glance of today's agenda. A quick introduction about Royal Cyber and mainframe practice and services, our internal assets and solutions, and the complete demo on today's topic, and of course, a Q&A session at the end of this topic. Regarding Royal Cyber is one of the fast growing IT consulting and digital transformation company specializing in IT services and solutions. We have 2 decades of experience and we do have 1,800 consultant across the globe and headquarters with Naperville, Illinois, USA. And we have our global presence, Canada, UK, Australia, New Zealand, and Middle East. We do have multiple offshore delivery centers here at India. We have a strategic partnership with a lot of technology companies like IBM, Microsoft, Amazon, Google, Heirlooms, Broadcom, and eventually we help our customers on digital transformation journey. Regarding our practice, we provide reliable and high performance solution for our customers within mainframe practice. Our offerings are in mainframe infrastructure management, wherein the VM, ZOS, and Linux, and other ISV product install and upgrade support, and mainframe application services, wherein we do application and production and application support, and also we do enhancements, more on automation related engagements. Enterprise modernization, wherein we engage complete modernization related tools, implementation, front end tool and middleware tool integrations as well. And support and managed services training, wherein we do a lot of 24 cross support and infrastructure support or managed services support kind of engagements. We have our in-house assets and solutions. We continuously work with Center of Excellence, wherein come out with some kind of tools for our customers' uh, problems. So these are some of the snapshot of our internal assets so far we built. We had a migration tool for Micro Focus COBOL to IBM PeopleSoft COBOL migration automation tool, and Endeavor to RTCZ migration, and Urban Code deploy like UCD was an IBM tool and Endeavor is CA. There is no direct plugin to integrate between Endeavor to UCD. We have our own customized solution for integrating Endeavor to UCD. Okay, Urban Code Deploy for Z. And we do have our own solution for customized domain specific code rule coverage tool, and Z DevOps solution implementation, and of course the password reset, and some kind of an middleware monitoring tool, which is Monitor Pro, which does monitoring of MQIAB on ZOS platform. With this, let us get into deep dive on today's webinar topic, which is mainframe source code migration to GitHub. Here we are going to discuss about overview of our source and destination SCM tools, business challenges, meaning why the migration is required, what's our migration approach, solution framework, and followed by the demo. Actually, you all know the Endeavor is a legacy SCM. which runs on mainframe operating system, which has a legacy green screen ISPF interface. And we have a set of operations or functions, add element, update element, move, transfer, sign in, sign out kind of functions which mainframe developers will go through to uh, to make the source control updates into Endeavor. Whereas GitHub is an open extensible architecture which actually supports a local Git as well as a GitHub server architecture. It supports on multiple platform support, meaning Z, OS or distributed or Linux, all the platform it can able to support. So we have an integrated SCM solution for mainframe application as well as a distributed application assets. And it also allows you to adoption for a DevOps orchestrations. So wherein we found Endeavor has kind of a limitations for the latest uh, tools and technologies. The business challenges, the current SEM has having a high licensing cost, the limitations on DevOps integrations, and interfaces are not so modernized, which is only legacy green screen, and skilled resources are in always in shortage. So to overcome this, we are going for a migration. Just to little bit, we'll understand our source SEM, how it is architectured or the application is configured so that when it is migrated, we could able to understand how these structures are transformed into the GitHub repository. So here we have an environments called student test, student prod, and a system named trading and subsystem named course admin, user admin. It is a sample application we have taken on the test server for the piece of demo migrations. It has a various stages, of course, and it is with the your test UAT and emergency and prod stages. So this is an actually limited scope which we took for a demo. Any SEM, when you wanted to consider the artifacts or the code, how it is organized, and the application execution environments, environment setup, as well as the build scripts and the user level of authorities, approval groups, these artifacts are taken into consideration. Our migration solution also considers this, and accordingly, the source artifacts are transformed and mapped into the destination SEM structure. Endeavor SCM has some kind of a details. Environment details is given here as a scope. So we are going to see how these artifacts are migrated into destination repositories. Our internal solution approaches follows ETL process, extract, transform, load. So during extraction, we are going to have our customized solution is going to extract the Endeavor artifacts and stores into the central repository. So we are using MongoDB document database as our repository because our legacy applications have huge line of code, and it is better to handle by your document database. And also, we are not only extracting or loading this elements, we also consider the complete metadata about SCM. The entire application metadata will be extracted and loaded into the central database. For any point of time, we can able to audit and validate the application assets. The transformation layer wherein we do the mapping definition, the mapping structure definition as per the destination repository or destination SCM, and how the GitHub structures or artifacts can be mapped into Endeavor artifacts. So we do the mapping definition. As per the mapping definitions, the transformation is prepared, and it is also a configurable item, and we can at any point of time based on the customer orchestration we can able to configure this, and based on this the transformation input will be prepared. That input can be given as an input for the load process. So the load process basically takes the input, and as per the transformation definition, that artifacts are getting uh, created and loaded into the target SCM. So here in this case, our target is GitHub. This landscape of a solution, the current state where your CA endeavor with the source code and structure and metadata, how it resides in the operating system. And your the target is going to be your GitHub, wherein it has some source members with files and folder structures, and of course with the metadata as well. And it helps you to go for a DevOps orchestration with the latest DevOps tooling with Jenkins or IBM Developer Fuzzy IDE and IBM dependency based build. And so these are the other tooling integration once it is transformed into the target SEM. So in between, this is what our solution is all about. So our customized solution is going to have the features which takes a proper input and form the extraction, and complete extracted elements will be loaded into or transformed into the JSON file, and that will be loaded into the MongoDB. So this is where the complete solution is all about. And the mapping or transformation layer is uh, works like this: your environment and system subsystem types elements getting transformed into GitHub specific structure called master branch, folders, subfolders, and files. Our solution frameworks actually, this is how it works. Our endeavor data load program is going to take an extraction and also transform to JSON, and the JSON file is be taken into the central repository, and the mapping definition will be prepared, and the transformation program is going to load the local structure. And from the local structure, the elements get pushed to your GitHub server. So the final output or outcome of this extract transform load is this: your extract outcome as a JSON file, and your central repository, the transformation or central repository happens in the MongoDB. Your extracted asset is loaded here, and final load is going to create your structure, training, course admin, and this is a type and the members in the GitHub. The solution has some benefit, like just because the legacy, we are get rid of legacy, so what kind of a benefit we are going to get? In fact, the solution helps you to restart from any point of failures, and it is going to avoid your huge licensing cost from the legacy software, and it also helps you to reconcile complete extracted assets, and it reduces the migration timeline because of the automated code, and it also minimizes the risk and errors. And we have a proper monitoring or progress captures in the form of a dashboard. So now we will get into the demo on how we are going to extract and the load, as well as transform and then load into GitHub structure. So let us get into the demo.
Let us say demo of migrating an application from Endeavor to RTC. We have several demo applications of varying complexity internally. For the purpose of demo, we kept application much simpler to demonstrate our solution architecture. We also wanted to provide you a behind the scenes of solution view. We definitely hope that this would be an informative session. Let's have a glance of how application is configured with Endeavor. We do see two different environments here, and let me try to get stage detail from the first. There are two stages, test and UAT from first environment, and from second I could see two more, emergency and fraud. So there are four stages, and let us try to get application structure from student test. Let me try to get like this. So we do see an application called training, and which in turn has subsystem called course admin and user admin. Let us go back for element details. Let me try to get all the elements of training application that it belongs to either of the subsystem of different types. Okay, so these are all list of elements belong to test and course admin or user admin, respective subsystem and respective types. And let me try to get an what do you call element content. So this is my source code, and if you want to have versioning, so these are the different versions for this application with CCID. So now we had a briefing of how application is structured here. So these application data we are extracting through automation, and extracted data gets stored in our database repository.
I'm now, we have seen how this source is structured, or source SEM is application is architecture into Endeavor. We have seen. So now I'm going to run my extra transform load options. So here is our interface, which helps you to migrate, transform, and load. So I'm going to do now extracting and loading your source assets into central repository. So here you can see the application is running and your source is getting extracted and kind of loaded into your MongoDB. So you can see this processing. So MongoDB load is complete. So now I'm going to do the transformation process wherein it is going to take up our mapping definitions and it will create your local structure. And basically it takes your completely as per the transformation, it is creating your local structures. You see the files are getting updated here. So transformation is complete, and now I am going to migrate this to GitHub. So this basically commits the complete local structure into this. You could see this GitHub, it is connecting to your GitHub repository and doing it. So your load is complete. So let me get into your MongoDB. So this is what your MongoDB, where the complete element structure is loaded. So this is my uh, Endeavor element master table. It's a Mongo database. Whichever view you are familiar, you can able to look into that. It's a table option, or maybe I would prefer to see in this option. So here, the element master, where what kind of a low file, environment, system, subsystem. So it is in the form of a JSON format. We have kept it and it is loaded here. At any point of time, I can query whatever is the required and get it from the extracted asset. So this is your Mongo. And let me get into your GitHub repository. So the repository got created and loaded here. If you see this, we have created and loaded. So this is the one is actually, see, updated 1 minute ago. This is a new repository got created. And when we ran it, this has got created GitHub testing new. And let me open up this. I see the training system. The training is the system defined under Endeavor. Now it has created as a folder under your branch, and course admin and user admins or the subsystems, which is kind of a subfolders, I could say. And these are the various types. Under each type, you'll have several members. These are all the elements, and here it is created as an files. This is a copybook.cpbook, and this is the commit command. We have made it, and this is the source file type, and these are all various COBOL files. The one which you have seen in this Endeavor element, right? ISPF panel where you are seeing a member. So this is here, it resides in your GitHub. So GitHub repository where your master branch and the folder training subfolder course admin, your type, and then your element. So this is your destination architecture. So with the help of an automated solution, we could able to completely migrate and load into a GitHub repository. And at any point of time, your extracted asset information can be validated from your MongoDB. So this remains as is even you get rid of your source system. Let us now look at the post migration validation checks. The basic validation metrics which we look at it actually for migration aspects, whatever the total number of program files which are got migrated from source to destination, as well as its size. So these are the two parameters we are considering, and here is the validation results we perform. So let us see on how this member count is tallying with the source and destination architecture. So I'm running my validation report for this, and it has created some file in my local system. So this is what the local system where I'm capturing this report. So if you look at it is talking about your system, subsystem, and type underneath whatever is the number of elements in the Mongo database or source, as well as your local structure. The same way, program type under these things, your number of elements in database as well as local structure. So all these parameters are getting tally with the source and destination, and the total number of elements from your source and the local destination architecture is also one of the same. Hope this validate and verifies the member counts. And let us now look at the file size. So file size, it has created another file in the same location. This is the file recording the file size. And this particular system has got only one system, and under a subsystem, each subsystem, we have various types and different members and the file size. So the file size is recorded in terms of bytes. So this much bytes each file is having the capacity. So let us say, for example, something it is ETRB003, 5000 byte, 5000 and odd bytes. Let me look at the same for my local. So this is the place where we our structure got created. So under course admin, source type, uh, the one which I referred is, one sec. Yeah, the one which I referred is ETR, okay, ETRB003. Let me see this. ETRB003 properties, 5265 bytes. All right. So ETRB003, this is the one, 5065. Right. So hope this agrees with this size. Okay. And I'll have a look at this one here. One another file which is ETRO005. Let me just highlight this one. This is what we are going to locate. ETRO005. So it is 15,715 bytes. So the file size is also again it's yeah, matching with your destination. So we are good with the file size as well. And so the post validation and verification we have performed for the element count as well as the file size. Thanks for watching this demo. Let me open up the forum for Q&A.